would find that point in the middle?
Find the critical values of the function.
Like we did in before, like act like there's no domain restriction. Can't we find the peaks and valleys? This problem right here, all we're going to do is add that one extra element to the problem. We already know what the max and min is around the edge. To include the inside, we're going to go back and do what we did first part of this 11.7, the previous section. Now, we don't actually have to calculate capital D, but we have to find the critical points. So how do I find critical points of a surface? What is it again that we do? Take the first partials and set them equal to 0, right? So I'm going to do this. Look, on this right here, okay, it's that, and then it's the stuff inside, right? Like that, the stuff inside. This right here we've done. The first example I gave you, we did this. We went around the edge. But now I need to be going on the inside. And to do that, I'm going to do my partials. What is that symbol? I must have hit that key. Yeah. All right, so what I'm going to do here is I'm going to take the partial of f with respect to x, set it equal to 0, and the partial of f with respect to y, set it equal to 0. And these are simple partials, right? 2x equals 0, and this 4y equals 0. What's the only value of x that satisfies that? 0. And then over here, y is 0. So the only way to satisfy both of these simultaneously is if you pick the point 0, 0. Is that inside of our disk? 0, 0 is in our disk, isn't it? So I would like to check here. I need to check the value of the function at this point. Right? This point lives in here, right? So now just what is the function's value at 0, 0? Well, just 0, right? Remember, when we went around the edge, it was 2 was the highest and 1 was the lowest. But now I'm looking inside and I'm getting 0 out. So now 0 is our minimum. Do y'all see the difference between these two problems? The previous one, edge only. This one, edge and interior. Yes?
So we would just write off the ones at this point.
Yes.
It would just be, so 2 is our max and then those are good.
Yeah, the answer to this, maximum value is 2. Minimum value is 0. Previous problem, maximum value is 2, minimum value is 1.
Cool.
Yes?
You also have to check the points inside the disk.
Inside the disk?
Yeah.
We still have to? Is that what you said?
Yeah.
No. That's what this test does. This test tells us any points x and y where we have any sort of bottom of the valley, top of the hill. I know that since this is the only critical point I have, there are no other low or high points inside of here. The only one I had was at 0, 0. So good, we don't have to check. Was there a question?
Yes, we didn't solve for the maximum here because we did last problem.
Because we did the last problem. Yeah, so when I said this check, just imagine we did all the work that we did before. Imagine we did that, we started with that, we did all that, we got our answers. And now we add this one extra part where we look on the interior. Yes?
So do we start on the outside before we go?
It's up to you. It's up to you. You can start on the outside and then do the interior, or you can do the interior then the outside. I just did it that way because we had already done it, right? Yes?
So with that one, it was a greater than or equal to. Did you have one where it doesn't include the edge?
If it didn't include the edge, then we would just do the inside. Okay. But the thing is, we have carefully stayed away from that, right? Remember I told you about the whole Ted Kaczynski thing and the boundary value problems and all that? Like, yeah. So, you know.
Yeah, I'd imagine it gets screwy at the edge.
Yeah, because you can have weird things happen. You can have weird things happen at the edges. So that's a whole other thing we stay away from. You're either doing find the local max and mins, like peaks and valleys on the entire domain, or we're finding absolute max and min on a closed bounded set, or we're finding max and min on a curve, which is a restriction, which is Lagrange. Do y'all see there's 3 different methods there, right? On the domain, you calculate capital D. On a closed bounded, you have to do what we did last class. And then if you're just on the boundary, alone on the boundary, that's Lagrange. All right, look at this one. Find the maximum and minimum values of f of x, maximum and minimum of the function f of x equals 4x plus 6y with the constraint x squared plus y squared equals 13. That's a circle again, isn't it? This is a circle. And it's a weird radius, but who cares, right? And this is a what? No, it's a three-dimensional line, so a plane. That's a plane. So we're taking a plane here, okay, and we are restricting it to this circle. We're only allowed to plug those points on that circle into the plane, and when we do that, we get this curve. It's only the points on that circle going into the plane. We get this. It looks almost like an ellipse, right? We're trying to find the highest and lowest points there. Looks like we should have a max and min there, right? Yeah, just one max, one min.
Yeah.
Oh.
Southwest Airlines, baby.
So I'll tell you this true story. We need a little comic relief for a minute. I'm going to mute myself. So wasn't. Good thing I had that. My background no longer has that picture.
Lessons learned.
Yeah, lessons learned, lessons learned.
Were you
Yeah, it's just my email.
or UTSA?
Okay. All right, back to this. So here we are. Lagrange. Why Lagrange? Because we have a surface that we're trying to maximize or minimize, and our constraint is an equation, right? Is an equation containing two variables. That's what lets me know it's Lagrange. Surface, constraint equation. Yes? I am unmuted, yes. Thank you. All right, so now I need to set up the three equations, right? I'm going to have three equations. First equation, I'm going to do it a little smaller so I can have more room to work. Equation 1, I need to take the, ooh, this is going to be easy, right? I need to figure out when the partial with respect to x is equal to lambda times the partial of g with respect to y. And then let me do equation 2. I need the partial of f with respect to y to be equal to lambda times the partial of g with respect to y. And then equation 3, I need the constraint equation, right, to be satisfied. Those are my 3 equations. Something tells me the algebra here is going to be simple because this is a plane. So the partial of that with respect to x is just 4, right? Equals lambda times, now the partial of g with respect to x is what? 2x. Okay, I've got that equation. All right, this one, partial of f with respect to y is 6, and then lambda times 2y. And I got my third equation there. I'll keep all that separate. Here, I can divide both sides by 2. Here, I can divide both sides by 2. What's that? Is lambda 3? Free. Well, lambda can be a lot of things and this be true, right?
Yeah.
I mean, lambda could be 2 and that could be 1, or that could be 4 and that could be a half. I mean, there's an infinite number of possibilities here, right? So do y'all see that this is not exactly what the other one was a second ago, right? The other one, it was like we could factor, and so the question is, what algebra are we going to do here? What you got?
We used our third equation.
How?
To give us some x's and y's so that we aren't just any x and y that could be,
Like solve this for x?
yeah, solve for.
That would be in terms of y, right?
Yeah.
And then if you solve for y, it'd be in terms of x. We could maybe do that. Let me take you through this one. Do you have a suggestion?
Yeah, so divide and check for 0.
Divide what?
Divide either lambda or x and then check for 0.
Okay, so did you say divide by lambda or x?
You can find a free variable, find a variable, and then check for the variable being 0.
Okay, so how about we do what we said we weren't going to do and divide by a variable, but we will check, if we divide by the variable, we're eliminating that possibility of it being 0, right? So we will need to check what would happen if it was, okay? So let's do that. Let's try and write this out logically. Suppose lambda is not 0, okay? Suppose lambda is not 0. Then I can divide both of these by lambda, can't I? Both sides by lambda. Both this divided by lambda, that divided by lambda. So equation 1 can be rewritten as x equals 2 over lambda, right? And equation 2, I can say is y equals 3 over lambda. Y'all buy that? That's only if lambda is not allowed to be 0. Now, if that's what x is, and that's what y is, then can't I go to the third equation, replace x and y with those two expressions, and then have a single variable in a single equation? I'll only have lambda, and I'll only have one equation. So equation 3 now becomes, what? X was actually 2 over lambda, but squared, plus the y, which was 3 over lambda, that squared must be equal to 13. Y'all see what I'm doing here? I've reduced this down to a single equation with a single variable. That's what you were saying to do, right? Like this? Okay. All right, now let's square each one of those. Let's try and solve this for lambda. So I square 4 over lambda squared plus 9 over lambda squared equals 13. Get a common denominator there. Well, there is a common denominator. 13 over lambda squared equals 13. Multiply by lambda squared on both sides. Plus or minus 1. Plus or minus 1, right? That's what lambda has to be, plus or minus 1. Do I need to show that? Multiply both sides by lambda squared, divide by 13, square root. We're good? Okay. Well, if now we have to take two different cases, don't we? We have to take two different cases. We said lambda is not 0, and now we have that lambda can be 1 or negative 1. So let me continue. I would be continuing at this point, all right? So now what I would say is this. Suppose suppose that lambda is 1, right? If lambda is 1, what does that imply about equation 1? Or what does equation 1 tell us? That x is 2, right? And then what does equation 2 tell us? That y is 3, right? And that would be our first critical point. Something important is happening at 2, 3. Not sure what yet, but something important. What else was I supposed to suppose? Lambda was a -1. If lambda is -1, equation 1 is what? X is -2. Then equation 2 is y is -3. So that's another point. The reason why I'm not saying that equation 3 is satisfied, equation 2 is because I already know that equation 3 is satisfied because that's where the lambda being 1 and -1 came from, right? Yes? All right, are we done?
If lambda could be 0, does that throw out all the other sequences?
Well, we have to look at what happens because we started this whole thing off saying suppose lambda is not 0, right? So now we need to check and see what happens if it is. If it is 0, that doesn't throw these away, okay? It just means that we would have other points to look at. So now I'm kind of done with that whole idea. And now I say suppose lambda is 0. And then what's wrong? What's wrong? What does equation 1 say?
2 is not.
2 is 0, right?
Yeah.
Then equation 1 says that 2 is equal to 0, which is not true. So I can't let lambda be 0. So if I let lambda be 0, then I have to be OK with the fact that 2 is equal to nothing. And then you could say equation 2 would say what? 3 is equal to nothing. So lambda can't be 0.
It also kills off our third equation.
Yeah, well, no, because you can't define what x and y are. So we're done in terms of finding our critical points. You okay? So let's get the final answer. So now I check what is f of 2, 3, and then what is f of -2, -3. You plug into the original function 2 for x, get 8, 3, 18. Is that right? 26. -26. Is my arithmetic right? 8 and, I swear, it's so funny. Okay. 8 and 18, 26. -26. Max and min right there, which we verify with that picture, right, that we had a highest and lowest point. So the good thing about this problem, the algebra is a little different, right? This algebra was a little bit different. I'm wondering if I should show you something else. Let's do this problem again. I want to use a slightly different approach because I want you to see that there's no right way to go about this. It's just you got to get there, all right? So let's go back to this part right here, where we were right here before we said, hey, let's divide by lambda. Let's try something slightly different. See if you can follow where I'm going to go with this. Suppose x is not 0 and y is not 0. So assuming x and y are both not 0, what I'm going to do is I'm going to take equation 1, and if x isn't 0, I'm going to divide both sides by x, right? And I get lambda is 2 over x. And then I'm going to take equation 2 and do the same thing. I'm going to divide both sides by y, and I'm going to get lambda is 3 over y. Right? Do you all agree with those statements? And if lambda is equal to 2 over x and lambda is equal to 3 over y, then they're equal to each other, aren't they? Right? And that means that 2 over x is equal to 3 over y. And that means that 2y is equal to 3x if I multiply both sides by x and then both sides by y. Understand what I'm doing? And finally, I can say that y equals to 3 halves x. I found a relationship between y and x. And now what I'm going to do is I'm going to go to equation 3. Equation 3, I'm going to write x squared plus what? Not y squared. 3 halves x squared must equal 13. And now I have a single variable in that equation. So if I square, I get x squared plus 9/4 x squared equals 13. Get a common denominator between those two. Isn't that 13x squared over 4 equals 13? Right, get 4 over 4, so you can put this together. And that, cancel the 13s on both sides, and you just get x squared is 4. Right? So x must be plus or minus 2. I know I'm going quicker through this, but if x is 2, then what's y? 3. If x is negative 2, what's y? Negative 3. Do you see you get the same two answers? Different approach. Grading these is not fun because there are different approaches. So I have to look and make sure that you're logically making sense. You're not skipping anything. You're covering all the bases, right? And your algebra could turn out to be real nice, and sometimes your algebra can turn out to be nasty. So, all right, let's do another example. Let's not look at this one until we're done. I'm going to leave that right there because that's the same theme, right? Same theme right there, and then our constraint is right there. And I'm sure I'm going to say suppose at some point, now I'll erase it. Who knows? I'm not sure what I'm going to do first here. All right, so I look at that. I'm trying to find the max and min, right? Trying to find the max and min of this function of two variables. So there's my surface, and my constraint is an equation containing the two variables x and y. I changed my mind. I want to look at it first. Can we look at it first? What you see here is the actual constraint equation. This is x cubed plus y cubed equals 16. So that's the domain on the ground. Why is this? I need to make this a little smaller. So let me show you the domain on the ground. There it is. And I'm going to pull the surface out of here a little bit so we can see there's a domain on the ground. If I take just the points in blue and plug them into the surface, we get this curve. Whoa, what the heck? I need to pull that out. Do y'all see that black curve right there? That's the points on the blue curve plugged into that surface. Now we do it. Partial of this with respect to x is y e to the xy equals lambda, right? So derivative of e to the xy is itself times derivative of what's up there with respect to x, which would be just y. And that's why there's y in front. Lambda times derivative of this left side, right? This is our g. That with respect to x, 3x squared. All right. Partial of f with respect to y is the same thing as this one, except an x in front. So x e to the xy equals lambda, and then the partial of the other one with respect to y is 3y squared. Right? Partial of g with respect to y. And then the equation is the equation. X cubed plus y cubed equals 16. All right. Find x, y, and lambda that make all three of these true at the same time. ideas here?
0 for all.
What's that?
0 for all.
0 for all? What do you mean?
0 for the y, 0 for the x, and 0 for lambda, because the 0 will take away the e to the x, y, no matter what happens.
Okay.
That's what equal to 0 equals 0.
So yeah, do you all see if you let x be 0, y be 0, that would be a solution to this? X is 0, y is 0. Same here, right? X 0, y 0 would satisfy. So 0, 0, but it doesn't satisfy this. But we need to look at that. I mean, that 0, 0 is obviously a solution to both of these, right? So we would want to consider that. So I'm gonna write that down because it was, somebody thought, let's do that. So suppose x is equal to 0 and y equals 0, right? Then if we do that, equation 1 and equation 2 are good, right? Equation 1 and 2 are satisfied if x and y are both 0. But equation 3 becomes 0 equals 16, right? Which isn't true. Right? So we can't let them both be 0, right? We can't let them both be 0. Now, could you let one of them be 0? Maybe. So would y'all like to look at that or do something else? Do you want to look at like, hey, what if x is 0 but y is not? Do you want to look at that scenario or I don't care. We know we can't let them both be 0. Try it? Let's see. Let's try it. Suppose now, okay, that I'm done with that thought. Suppose now x is 0 and y isn't 0.
Just looking at that, can we just, if we suppose x is 0, can we identify what y would be right away by looking at equation 3?
Yes, that would satisfy this equation, right? If x is 0, x is 0 and y is not, we can figure out what y is, yes? But are you allowed to do that? Are you allowed to let x be 0 and y not be 0? Let's see. I agree, we have something here. What if x is 0 here and y is not? If x is 0, is this side 0?
Yes.
What about this side? Can this side ever be 0?
If y is 0.
Only if y is 0, right? Because e to some power is never 0. So how am I going to get y times something that's not 0 to be equal to 0 if I'm not allowed to let y be 0? That makes sense? So I'm going to continue with this. Suppose this. Then equation 1 tells me that y e to the xy must equal 0 by letting that x be 0. And now this, what? Can't be true. You have to realize that that can be true, right? That's not 0, because I said it's not 0, and that can never be 0. So the only way these two multiply to be 0 is if one of them is, which means you can't do this. You can't let x be 0 and y not be 0. We throw it out, because you can't even satisfy equation 1. I guess I'm seeing some looks. What's wrong? You have a question?
Oh, I was looking at equation 2.
Equation 2, would equation 2 be okay with this? If x is 0, this is 0, right? Then either lambda is 0 or y is 0, right? So you could keep going with that. But the problem is if you let x be 0, then y turns out to be 0, then you're back to the first case. But we're trying to cover all our bases here. So I'm going to move on. What about the other way around? Suppose y is 0 but x isn't.
Same problem.
Same problem, right? But this time for equation 2, I believe we have a problem, don't we? So on this one, if you look at equation 2, it now says that x e to the xy must equal 0, but that can't be true. So here's what I can tell you. We can't have x and y be 0 at the same time. That's not possible. And we can't even have one of them be 0 and the other not, which means they can never all be 0, never both be 0.
Can we solve equation 3 for a variable and plug it in?
Yeah, you could solve this for y if you wanted, or x, and then plug it into one of these. But if you do that, do you agree? Let's just say you solve this for y, right? And then you would have, plug that in, then you would have x's going in for y. If I replace that with x's, do you see that we still have two variables in that equation? Like we have the lambda and the x still? Same with this. If you replace the y with something with x's, you're still going to have two variables in a single equation. I'm not saying we shouldn't do it. I'm just saying that it doesn't take us immediately to some result. Is there,
We'll do that.
did you have a suggestion? No? Okay, y'all ready to see how I'm going to go next step? Pardon me?
Couldn't they both be
Equal to? Oh, it could be. It could be that the answer is 2.
Looking at the other one at the very least.
So the important thing about these Lagrange, at least the way I look at it, is can you get to the answers by satisfying all 3 equations? So here's the way I think I'm going to approach this. See this e to the xy? Do you see that that also has e to the xy? Do you agree that if I solve this for e to the xy, solve that for e to the xy, then I can set them equal to one another? Yes? Now, the only way I'm allowed to do that is if I divide through by y, though. If I divide by y, I'm promising y can't be 0. But I've already covered what happens if y is 0, right? So I don't need to worry about that, right? Also, to solve this for e to the xy, I'm going to divide both sides by x, but I got to promise you x can't be 0. But I've already talked about what happens when x is 0, right? So now my new thought. Suppose x isn't 0 and y isn't 0. Now, look, I'll tell you right now that if I would have started this problem very beginning, this is what I would have started with. I would have done this step first, okay? But what we did was worth it because we would have eventually had to cover those cases. Eventually. We just covered those first. So x and y are not 0. Equation 1 becomes e to the xy equals lambda times 3x squared over y. And then to save space, equation 2, normally I'd write this on the next line. Equation 2 becomes e to the xy equals, what was it, lambda 3y squared over x. Right, so I just divided both sides here by x, divided both sides here by y, double check. Yeah? Set them equal to one another, right? If this and this are the same, set those equal. Therefore, or I'll put so, we have lambda times 3x squared over y equals lambda times 3y squared over x. And now let's clear the fractions. So I'll multiply both sides by x, I'll multiply both sides by y, which I'm allowed to do so long as I promise you that x and y aren't 0, which I've already assumed from the very beginning, right, of this. So this becomes lambda 3x what? Cubed equals lambda 3y cubed. Yeah? We're almost there. I'm not going to divide by lambda, okay? What I'm going to do is I'm going to move everything to one side. So let me do lambda x cubed minus lambda y cubed equals 0. I'm going to pull a lambda out. And if I pull lambda out, I'm left with x cubed minus y cubed equals 0.